Hello students, so let's continue with the MCQs. The first MCQ is, which of the following ray diagrams is correct for the ray of light incident on a lens as shown in the figure? So at the top the figure is shown where an incident ray is passing through focus and is incident at the convex lens. We know that when a ray is passing through the focus, incident ray, when it is passing through focus after refraction, it becomes parallel to the principal axis in case of convex lens. So here A is the correct diagram because the ray becomes parallel to the principal axis. Now the next MCQ is, which of the following ray diagrams is correct for the ray of light incident on a concave mirror as shown in the figure? So when we look at the figure which is given in the question, the incident ray is parallel to the principal axis which is incident at a point on the concave mirror. So you have to choose the correct ray diagram. It means the correct reflected ray for it, as it is a case of concave mirror. So we are going to find the correct reflected ray and hence choose a correct ray diagram. Now, if the ray is parallel to the principal axis, we know that it passes through focus after reflecting from a concave mirror. So, D is the correct option if we look at the four diagrams, because that is a diagram in which the reflected ray is passing through the focus of a concave mirror. So, figure D is a correct answer. Now, the next question is, a full-length image of a distant tall building can definitely be seen by using four options: a concave mirror, a convex mirror, a plane mirror, both concave as well as a plane mirror. We know that out of these four options, convex mirror has wider field of view as it is curved outwards and it always produces diminished image. So, a full-length image of a distant tall building can definitely be seen by using a convex mirror. By plane mirror, it is possible only if, yes, comparatively, the size of the plane mirror required for it will be very huge. So, we will choose the option B. Now, no matter how far you stand from a spherical mirror, your image appears erect. The mirror may be plane, concave, convex, or either plane or convex. You have to choose the correct option. Now we know that in plane mirror, the image appears erect. In convex also, always for all the object distances, image is erect. So, A and C, both of them produces erect images, and D contains either plane or convex. But remember, in the question it is given no matter how far you stand from a spherical mirror. So convex is a spherical mirror. So C is a correct option. If in the question they write no matter how far you stand from a mirror, your image appears erect, then we'll choose D option. But for the question given here, spherical mirror, you will be choosing C option. One half of a convex lens is covered with a black paper. What type of image will be produced? Half, full, 1/4, no image is produced. We have discussed such question in one of the previous videos also, where instead of covering the convex lens half with a black paper, the question was that we have the strips of black paper on a convex lens. Okay, and so I have discussed before also that from any point on the object there are not two rays coming out. Okay, there are infinite rays which are coming out from any point on the object, and they strike at different points on the convex lens. Okay, so it means even if half of a lens is covered, the rays coming from any point on the object are going to form the image after refraction through a convex lens. The only difference is when half of a convex lens is covered with a black paper, full image will be formed but intensity will be less. It will be less bright. So B full is the correct answer. Now the question is, the focal length of a convex mirror whose radius of curvature is 32 centimeter is. Now we know that radius of curvature is given and focal length is half of radius of curvature as focus lies midway between center of curvature and pole of the mirror. So half of radius of curvature means half of 32 centimeter, that is 16 centimeter. So B is the correct option. Next question is, speed of light is maximum in a medium whose refractive index with respect to air is. There are four options: 1.33, 1.5, 1.2, 1.67. And we know the formula N is C upon V, where N is refractive index and C speed of light in vacuum, V is speed of light in the medium. So speed of light will be maximum in a medium whose refractive index is minimum, the least, 1.2. So C is the correct option because we know N is inversely proportional to V. Now the next question is, a ray passing through which part of a lens emerges undeviated? Hope you know the answer. Optical center. C is the correct option because this is the only point where if the ray is incident, then it goes undeviated. So C is the correct option. Now the next question is, which of the below diagrams illustrates the path of light ray as it travels from a given point X in air to another given point Y in glass? So if we look at the ray diagrams, we know that the incident ray which is coming from X, okay, it is obliquely incident at a point on the glass surface. Now we know that when the medium changes, it is going to bend, it is going to get refracted, and refraction will be in such a way that the ray will bend towards the normal as the speed of the light reduces. So in A option, it is wrong because the ray is moving along the normal after refraction, which is wrong. It should move towards the normal. In the B diagram, it is going undeviated. That is also wrong because it is incident obliquely and the medium is also changing. So there should be refraction taking place. C is wrong because in C diagram, the ray is incident normally. In that case, there should not be refraction taking place. It should go undeviated. And fourth option, D, is correct because the incident ray is bending towards the normal after entering into the glass. In this question, we have a spherical mirror and a thin spherical lens have each focal length of 15 centimeter. The mirror and the lens are likely to be, four options again, both concave, both convex. The mirror is concave and the lens is convex. The mirror is convex and the lens is concave. We know that as both of them have focal length 15 centimeter, which is positive, this is possible when both of them are convex. So both convex is the correct option, B. Now the last MCQ is, an object is placed at a distance of 10 centimeter in front of a plane mirror. Then the distance of image from the mirror will be 5 centimeters, 10 centimeters, 20 centimeters, 0. We know that if object distance is 10 centimeter, then in case of plane mirror, image distance is equal to object distance. It means image distance will be 10 centimeter or distance of image from the mirror will be 10 centimeter. But yes, the image lies behind the mirror. So B is the correct option. Now the next question is, the image of an object placed in front of a convex mirror is formed at the object itself, twice the distance of the object in front of the mirror, half the distance of the object in front of the mirror, behind the mirror. Now we know that convex mirror is a diverging mirror, and in this case, always for all the object distances, image is produced behind the mirror. It is always virtual, erect and diminished. So D is the correct option, behind the mirror. This is the last MCQ. The radius of curvature of a concave mirror is 12 centimeter then the focal length will be 12 centimeters, 6 centimeter, minus 24. C option is minus 24 centimeters. Last option is minus 6 centimeters. We know that if radius of curvature is 12 centimeter, focal length will be half of it, 6 centimeters. But as it is a concave mirror, it should be negative. So D is the correct option. Hope you have understood all the MCQs, students. So we'll continue with the MCQs in our next video. Goodbye.